What's going on everyone, you're back with your boy Jono for another quick math lesson. Today we're going to look at the interior angle of different polygons and not just our 4 or 5 sided shapes. We're going to go all the way up and develop a rule for any sided shape because it really comes down to one fact that we can see really easily. So the only prior knowledge that we absolutely need to know is that a triangle's interior angles equal 180. If you do need to prove this in a test condition, please check out my last video because we go in depth about why the interior angle sum of a triangle is 180. But this key bit of information is going to be the basis for our proof that we're going to come up with in this lesson. So let's just say that I've got this trapezium here. It's got 4 sides. We could have used a square or a rectangle, but a trapezium looks a bit harder, so we're going to start with that. All I want you to do is pick a vertex. I'm going to pick this one on the top left. The only thing you need to do is join up that vertex to another vertex using a dead straight line. So for this one, I'm going to cut it right through the middle. I don't want you to draw a line to another vertex that it's already touching, right along the edge. I want you to actually cut the shape in half for this example. So that red dotted line that I've put in has actually made 2 shapes. I've got a triangle down the bottom and I've got a triangle up the top. Because I know for sure that the angles in that first triangle equal 180 and the angles in that second triangle equal 180, that means the total sum of all the angles within this shape must be 180 plus 180, which is equal to 360 degrees. You probably already know that a square has 360 degrees because it's got 4 right angles. But this is a more concrete proof because we're not just talking about squares and rectangles with our right angles. This will hold up for any 4-sided shape because when I connect those 2 dots, 2 triangles are formed. So the only thing we need to know for sure for this is that we had a 4-sided shape and we made 2 triangles. The only thing that we need to know moving forward is I need you to pick a vertex at the start and then just join it to any other vertex that you can that it's not directly connected to. We're going to have a look at another example, but if you've got that locked in, I guarantee you're going to find this pretty cruisy. So this time I've got a pentagon and I'm going to take that top vertex. All I've got to do is draw a dead straight line to another vertex that it's not connected to. So if I go down to this one and then to this one, because both of them are connected, I can see pretty quickly that I've got 1, 2, 3 triangles. Each triangle is equal to 180. So I've got 180 plus 180 plus 180, which is equal to 540 degrees inside this pentagon. Again, the important takeaway for us is because I had 5 sides, I could make 3 triangles. There is no way that I could make more triangles from that same vertex. It's just impossible. This 5 sides to 3 triangles is the important relationship that we absolutely need to know moving forward. Now, if I look at a hexagon, it's got 6 sides. So I'm pretty confident I'm going to be able to make 4 triangles using this method. So this time I'm going to take one of the ones at the bottom and just join it to any other vertex that it's not directly touching. So I've got 1, 2, 3 possible connections it could make, which makes 4 triangles. So if I've got 184 times, that's equal to 720 degrees. And that is the interior angle sum of a hexagon. You might be thinking that, yeah, this makes sense for all of these shapes that look really normal. What happens if this shape is a little bit different? I said that this rule holds up for absolutely every shape that's got this many sides. So if I've got a shape like this, it's got 5 sides and it looks really weird. I'm going to take the point in the middle there and again join it to any vertex that I can that it's not already connected to. So this one I can go up to the top, down to the bottom, and they're the only 2 connections that I could make. That means that I've got 5 sides, 3 triangles again, which means that this is equal to 540 degrees, just like our pentagon at the start. Just because this looks different doesn't change the fact that the interior angle sum is 540. You could probably tell that that one in the middle, the one that I started with, is going to be a really big reflex angle, but the other ones are much smaller, probably all acute angles, and we still get to that 540 if we measured this out with our protractor. So I don't want you to have to draw these lines in every single time you get a shape. There is actually a rule for this, and it makes quite a lot of sense from what we've been doing. The rule comes from 3 bits of information. The first is that however many sides a polygon has, we can make 2 less triangles by connecting one vertex to all the other possible ones. So if I said that n is equal to the edges present in a certain shape, we can say that n minus 2 is equal to the number of triangles that can be made by joining the vertexes possible. We saw this in every single example. 4 sides, 2 triangles. 5 sides, 3 triangles. And this holds up every single time, even when we get to incredibly big numbers. So if that's one part of the rule, the second part of the rule is that each triangle is equal to 180 degrees. We use this in our examples to go 180 plus 180 plus 180. We don't want to do repeated addition when we can just use multiplication. So this 180 times as by the number of triangles we have is going to give us the interior angle sum of any polygon. So the way that we write the formula is the 180 degrees from the triangle is multiplied by the number of edges minus 2, which again tells us the number of triangles, and we just have to do that in one step. Make sure that you do have it in the brackets. If you don't, the 180 is going to multiply with the n first, and then you're just going to take 2 from there. Your answer has to have a 0 at the end. Sometimes my students do make this mistake and get a weird answer. Please just double check that you've got a 0 at the end because it's 180 multiplied by a number. It's going to end in 0. So in a more algebraic form, you're just going to see this as 180 bracket n minus 2 bracket is equal to the interior angle sum. So all you've got to be able to do is count up the sides of a shape, and you're going to get full marks every single time. So if we just see this in action, our trapezium we said was 360 degrees, 4 sides means that we can have 2 triangles, 180 times 2 is equal to 360. We know that's right. So for our 5-sided shape, we've got 180 bracket 5 minus 2. So 5 minus 2 is 3, 180 times 3 is 540 degrees. That's what we got when we counted them up. So we know this one's right as well. So if we look at something like an octagon with 8 sides, that would be 180 multiplied by 8 minus 2 or multiplied by 6. 180 times by 6 is 1080, and that would be our answer. No need to double check this. So this formula is incredibly easy and makes a lot of sense. Being able to prove these kind of facts using pre-existing knowledge is an incredibly important skill in mathematics, and this is a nice little taste. If you get really good at this, this is something that can really open up a lot of doors when we move into harder mathematics moving forward. Thanks so much for watching this lesson, guys, and I'll see you later.